Hello students, in this video we will learn how to make a program of linked list. In a previous video I have discussed how linked lists are conceptually working and you can refer to that video to understand the conceptual working. Here we will look at the programming aspect of LinkedIn. So coming to the programming aspect of LinkedIn, first we will include the stdio file. Why do we include this file? For using the printf scanf statements. Without stdio we cannot use them. Then we require malloc.h for dynamic allocation of memory. In case you are not aware of how malloc works, then I have a previously recorded video. The link I will provide in the description box. Now for the linked list, first of all we have to declare the node structure. That is, what does the linked list consist of? Generally it is a data part and it is a pointer to the next element. This will be of the recursively same type that the linked list elements are of. So struct node star next. So these two members are there in the linked list, and this defines the data and the pointer. Then what do we require? We require a struct node type of pointer, start pointer. Why we need the start pointer? Because it contains the link to the first element of the linked list. That is why we need the start pointer. Now we need to define three functions before we can actually define the main, so that we can use the linked list. So what are those three functions? We require a add element function. In add element we have to pass an item that we want to add in the linked list. So we'll define its body. Then we need a delete element function which will delete an element from the linked list. And then we need a traverse function which will visit each element of the linked list exactly once. And then we will define the main, in which we will call all these three functions. So in add element, first of all, what do we need is, we need to create a new node that we can attach in our particular linked list. So for that we need a struct node type of pointer, temp, and in this we will take a memory block using the malloc function. So we need to typecast the memory as struct node star type, so that we interpret the memory that the malloc will return as a struct node type of a structure. So we call the malloc function. And how much memory do we want? We want size of struct node. So this is the size that we want, this one, and this size is returned by size of. Then malloc will allocate those many bytes, and then we are typecasting that memory as a struct node pointer, so that we can refer to data and the item within that memory block. Now using the temp variable we will use a pointer and we will set the data as item. Then we will set the temp next, that is the pointer to the next element, as start. Why we are doing this? Because whatever was there in the linked list previously, we are appending at the beginning of the linked list, that is insertion at beginning. So the new element will appear at the top of the linked list. That is why we are shifting the other elements towards the second element. So temp next will point to start and start will point to temp. This will create a new element in the linked list, and we can print a friendly message that element is added. And we can print a message also which element is added. So we can put %d here, and we will put the element item has been added to the linked list, and we'll put a semicolon. So this is the add element function. Now we move to delete element. In delete element we have struct node type of pointer temp, and initially we are storing the start in it because we have to delete from the start. Now we will check if temp is equal to null. In that case the list is empty, so we will print. So we'll put endl and we'll say list is empty. Otherwise, in the else part, what we will do is we will remove the element. So whatever element we are removing, we want to return that to main. So we will say int I is equal to 0 initially, and at the end of the function we will simply return I. And in the else part, what we are going to do is we have the list in the temp, so we will copy the element. So I is equal to temp ka data, yes, and then start is equal to temp ka next, so that start will now point to the next element. So we have removed the temp from the list, and now we will free the temp. So with these steps we are going to delete the element from the linked list, and we can print also. So we'll print printf /n element deleted and %d, and here we will put the element as I. So we will print give a friendly message to the user that this element has been deleted. Now in traversal we have to visit each element, so again we need struct node start temp, and in this we will copy the start of the linked list. Now if temp is equal to null, that means the list is empty, so we will simply printf that the list is empty. So we cannot traverse it basically because there is nothing in the list. So we'll just put a semicolon here and put it inside the bracket. And then in the else part, what we will do is we will traverse the list. So we will make use of temp while temp is not equal to null, and then we will simply print the element printf, and we will say %d and temp's data. We will print on the screen. And then we will say temp is equal to temp ka next, yes. And one more thing we'll do is before the while we will put a printf which will say the elements in list are /n, and we'll put start and pointer here, and then within the printf within the loop we'll put a pointer, and at the end of the loop we will put another print. So we'll say printf and we'll say null at the end of the list. So it looks very understandable if you put like this. So we have all the three functions ready. We have add element, delete element, and traverse. Now we will call these functions in main. So in add element we will say 10 first, then again add element and we will say 20, yes. Then we will traverse the list, then again add element and we will say 30, and then we will traverse, and then finally we will delete element and we'll simply traverse the list. So we'll save this. Let's give a name to this particular program. So in the file, so just taking time. Okay, so in my documents, I will give this a .c extension and we'll name this as linked list. Simple linked list .c and save. So we have saved the file. Now is the turn to execute it. So we'll compile the code. So there are no errors. So now we'll run. Okay, there's a problem. It's an unexpected semicolon before while. Okay. Okay, we did not put a semicolon here. That is the error. So let us execute it again. Compile. Okay. Now this time there are no problems. I think yes, no errors are there. So we'll run it. So we can see here element 10 is added, element 20 is added. The elements in the list are 20, 10. So since this is insertion at beginning, 10 will shift and 20 will become the first element. Then when we add 30, 30 becomes the first element, then 20, then 10. And then finally when we delete an element, 30 is deleted and the new list is 20 and 10 in the list. I hope this video is useful to you for using linked list for insertion at the beginning. And I will, in the subsequent videos, I'll be recording for insertion at end and deletion at end. So make use of these videos, share with your friends, like, subscribe, comment. Thank you very much.